Hello everyone, hope you are doing well. Welcome to another video and also welcome to my YouTube channel if this is your first time watching a video on my YouTube channel. In this video, we're going to be learning how to use John Reaper. John Reaper is one of the most popular tools to crack hashes. So I don't want to lose your attention, so let's jump into it. So the first slide is how it's really important to know the definition of what John Reaper is and what's the purpose of this tool. So John the Reaper is a password cracking program used in cybersecurity to detect weak passwords by testing many possible passwords combinations against encrypted password hashes. Security professionals use it to audit and improve system security. The first thing that you need to do, obviously, is just to install the tool and package on your computer. So if you're using Kali Linux or any distribution like Ubuntu, I suggest you to use apt-get install John. But if you're using another distribution like CentOS, I recommend you to use DNF, a package manager, to install John. So let's see how it works. So obviously to install, I've already had John Reaper installed on my computer. So I want just to show you how to install it. apt-get install John. So as you can see, John Reaper is already installed on my computer with version 1.9.0 Jumbo. But if you haven't installed on your computer, so you probably see the longer process and the progress bar to install the packages and the tool on your computer. So now we have John installed on our computer. Let's see what we got on the slide here. So 5 rules, cracking basic hashes. The word list, the most important argument and or option in John Reaper, because if you want to crack the hashes, you need to have a file ready password file to match each line with the hash string. Second, if you hash the same input, it's the rule. If you hash the same input, you always get the same output, no matter how many times you hash the same input. So, for example, we have a string like apple. If you try to hash the string with the same hashing algorithms many times, you always end up with the same output. That's why John Reaper asks you a word list to compare those two. It hashes line by line the word list you give it, and it tries to match and compare those two hashes. If it matches, you manage to crack. Third, do not forget most of the time you need to specify and determine the type of the hashes like SHA-256 or 512. John Reaper by default does that, but if you specify the hashing algorithms that you're about to crack, it increases your chances to get your desired result and crack the passwords. But if you don't specify, it kind of reduce your chances and decrease your chances to get your desired result and crack the hashes. So fourth, you can list all formats in John Reaper using John dash dash list equal format. So you don't need to memorize all of the formats that John Reaper support. So the only thing that you need to do is just come here. The first thing that I need to run is John help here. As we can see, it lists all the arguments and options that you can see over here. So list should be probably over here, yeah. So if you don't know what kind of option that you can use for what kind of sub option that you can use for list, you can easily write John list help, and as you can see, it lists all of the options that you can use for a specific argument list here. So our desired option over here is format. So we're going to use format to see what kind of hashing algorithms John Reaper support. So let me clear the screen here. John list format. And as you can see, it lists all supported format in John Reaper hashing algorithms that we can use. So if the hashing algorithms, for example, is SHA 512, you need to be specific for John Reaper. So John Reaper use different specific format um, inside in it. So for example, let's say we have a hashing algorithms SH512, but the format that you need to specify in John Reaper should be, for example, raw SH256 or 512, which is over here. So you need to be specific with John Reaper, and John Reaper support almost all hashing algorithms, but the way that you need to put it in the format argument is kind of different, and you need, for example, for some hashing algorithms, you need to include row dash at the beginning of the hashing algorithms. So enough with talking, let's come here. And so let's see how we can crack a simple hash. So over here, the first step that you need to do, as I just explained to you, you need to identify what kind of hashing algorithms you're using. There are some tools, online tools like hashing identifiers, which one of the most popular that I'm using is hashes.com. It's kind of very reliable and trustworthy about identifying the hash types. So, but if you don't like if you don't like using online tools like hashes.com, there are some tools like written in Python, hash id.py, which is a program written in Python programming language, and it helps you to find the and it helps you identify the hashing algorithms. I'm gonna cover both of them, don't worry, but for now I'm just gonna use hashes.com. So first of all, let's hash a string. So uh, for example, I'm gonna hash hello, and I tab on generate. So as you can see, it generated two hashes in two different formats, one for MD5 hash and another one for SHA1 hashes. So I'm gonna go for MD5 hash for now, and I come here. So the first thing that we need to do is to save this hash in a file. So in order to save it, I write echo my hashes, and I append this and I put the string or assign the string to a file, and I'm gonna call it hashes hash.txt. So as you can see, if I list my directory and files, the hash.txt has already been created, and I'm gonna cat it hash.txt, and as you can see, the hash is successfully assigned to this file. So let's say we found a file with hashes, but we still don't know what type of hashes it is. So the first thing is need to identify the type of the hashing algorithms. So we hash the string over here, and obviously we know it's MD5. But let's say someone else doesn't know and has no clue about the hashing type over here. So it copies and pastes it over here, and it click on submit and identify. And as you can see, this site successfully could identify the hashing algorithms that we use. So which is MD5 over here. And as you can see over here, we copy the MD5 hashes. So now we know the type of the hashing algorithms. So let's come over here, and we need to see what's the specific format in John Repair that supports. So we use John list formats. What we are looking for, we're looking for MD5. So it lists all MD5 all string that includes MD5. So let's looking for MD5 over here. It should probably be somewhere here. Yeah, as you can see, I found it raw MD5 or raw MD4. If you're using hashing algorithms in MD4, you can use MD4, but for now I'm using MD5. So let's do it. I'm gonna use John help, okay? So the most important thing that we're always using in John Reaper to crack a hash is word list. As we saw in the slides in the PowerPoint, we always use word list argument and options and to crack our hashes, and it's a ready password files or ready word list file to crack the hashes, and we use the word list argument or option to specify the path to our file or the word list. And another important thing that I'm going to show you here is format. We need to specify format most of the time in order to increase our chances to crack the hashes. And for now, just that. So let's use it. John format raw MD5. Sorry, MD5 should be capital in uppercase. Sorry, in uppercase. And word list, the path to your word list, which mine is over here. And at the end, you need to specify the hash file, which is the hash.txt. As you can see, as soon as I run this program, as soon as I run this command, it could crack the hashes, and it found hello. So we successfully cracked the hash, and it found hello for us. But I want to mention something over here. If I rerun the command here, it shows nothing. Why? Because John Repair, after cracking a password successfully, it tries to save a result in john.pod, which by default it's saved somewhere here. If I ls he, sorry, if I ls lash here, you can see a directory names .john over here. It's always in your home folder. So .john, if I change directory to .john and I list my files over here, as you can see, I have a file named john.pod over here. And if I cat it here, john pod, you can see successfully it saved the result over here. So John Repair does that in order to save time and do not crack over and over again a hash string, in order to save time, and just that, in order to save time and put it in the result to save time, just for that. But if I remove this file, john.pod, and if I come over here and rerun the John to crack the password once again, it shows the result because I deleted the result which was saved in john.pod. As you can see, it shows the result once again, and it's gonna save the result in john.pod. Okay, so but sometimes we'll try to crack some different hashes. For example, we want to crack a list of hashes which is related to passwords, and sometimes we want to crack some hashes, a bunch of hashes that is related to username. So we don't want all of them to store or save in john.pod. We have a solution, and John Repair has an argument named pot. If I run a john dash dash help, as you can see, we have a pot, and you can choose your and specify your desired file name to save your different result and different hashes. So, for example, if you're cracking hashes related to passwords, you can name it password.pot. Or if you're cracking hashes related to username, you can name it username.pot. So let's see, for example, um, let me rename it to the passwords. Let me leave it like that. So I run John format raw MD5 and word list to rock, and I'm gonna specify the name of the file that I want John Repair to save the result. So pod, for example, username. I go for username.pod, and at the end hash.txt. As you can see, it shows the result, and it's gonna save the final result somewhere in username.pod. And where is the username.pod? It's in the current directory. If I list the files and directory over here, as you can see, we should find username.pod. And if I cat this file pod, it shows the result that's saved in this pod. So that was for this. So let's go back to our PowerPoint and go to the next slide. I'm gonna come back to this topic later on, but first thing that I would like to cover before covering that is single crack mode. What is single crack mode? Single crack mode in John Reaper is a password cracking mode that tries to guess passwords by using information related to the user, such as the username or personal data, and applying simple variation to it. For example, let's say we have some information about that hashes. For example, we know this hash is related to the username someone like John, and the username is John and full name John Smith. The thing that John Reaper does is just manipulating and playing with the characters and replacing the character. For example, capitalize the string, turn it to the uppercase, turn it to the lowercase, try to add some numbers at the beginning, try to add some number uh, at the end of the string, try to reverse the string, and so on. It tries kind of to manipulate the string in somehow and replacing the character. So let me show you how it works. If I run John help over here, and if I scroll up here, there's an option, as you can see, single. Okay, single. So we need to use that options, but we also need to provide some information about about that hash if we want to use single mode. What I mean, let's come back here in let me search it again and come here. So let me cat my word list first. For example, cat rock, okay, rock dash 05. So let's say we want to crack, for example, monkey, a hash monkey. Okay, let's hash monkey over here. Oh, let's for example say Milad. It's better because it's a username, it's a name. It would be easier. Okay, so I'm gonna hashes M-I-L-A-D. I'm gonna hash this string over here, and I copy that, and I assign it to the hash.txt file. I'm not gonna append it. I just gonna rewrite the whole hash.txt. So that's why I just use one um, greater sign. Yeah, greater sign. Yeah. Over here txt, and if I cat my hash.txt, as you can see, we've successfully assigned the new hash into the hash.txt file. So the first thing that we need to do, as you always remember, is to specify the type of the hashes. So I copy and paste it over here, and the hashes.com successfully identified the type of the hashing algorithms. So we know it's MD5. We can proceed with cracking the hashes. Okay, so we come over here, but before using John repair, as I just told you, we need to provide some information about what are we about to crack. Okay, so open the file, the hash.txt. Before the hashes, you need to write down your information. What I mean, so put a colon here, and for example, I put Milad. Okay, it's all the information that I have about this uh, hashes. So for example, let's see, we have a computer with the username Milad, and we guess that the username Milad has put some password like Milad123 or anything, something like that, or the user Milad tried to capitalize the string for the password and something like that. So that's all the information that we got for these hashes. So and that's why we provided these informations to the John repair in order to help to crack it using single mode. That's all the information we have here. So we save it and we quit. So we come here and use John format raw MD5, and we're not going to specify that path is optional. You can specify or not. But the new option that I'm going to use, or argument I'm going to use here, is single. Okay, and I'm going to use hash.txt. So it's already, I think it couldn't find it. Yeah, it couldn't find John. Let me remove it. John conf. Let me remove it. Format single hash.txt. So it couldn't find it, unfortunately. Let me try another one. Uh, Let me go with Milad all uppercase and echo to hash.txt. Oh, sorry, hash.txt. And if I win hash.txt. Let me add my information at the beginning. Milad, John Ripper. It's weird. Format, single raw MD5 hash dot. I don't know why it's doing this, but let me try something else. Let me vim hash.txt and come over here and, for example, Melvin, and let me try with Melvin. So open vm hash.txt. So I'm gonna save it and let's rerun it once again. It's weird why it couldn't find it. I have no idea why. I think I'm doing something wrong. Let me remove rf username dot pot and let me go to John cat John dot pot. No, it didn't find it. I don't know why. Raw MD5 single. Oh, sorry. I need to come back here. So unfortunately, it couldn't find it, and I have no idea why. But let me clear the screen and exit, and once again come here, and let's see MD5. It's for Melvin, which is already we got here. Milad. Let me come here and echo to hash.txt. Sometimes it's kind of buggy. Cat hash.txt. Okay, so let's see. John format raw MD5 single hash.txt. So yeah, it shouldn't work. Hash.txt. I come over here. What's that? Yeah, okay. So let me see. Yeah, as you can see, it worked, but let me try another information to provide with it. Let me rf john.conf. So let's vim hash.txt and change the milad because I put exactly the same information as the hashes, as the string that we hashes. So let me change it to all uppercase. And now rerun the John. It says using default loaded one password. So let me cat John conf. No, somewhere over here or not? No, couldn't. Let me vm hash.txt. So let me do Milad and let me do John format raw md5 single hash.txt. Using default input encoding loaded one password hashes, no password hashes to crack. It's really weird. Hash.txt. Let me change it actually. Let me change it to something all uppercase. And so echo this one to username hash.txt, and let me vim username hash.txt and put what the string. Okay, Mila, just let me put small case here and come over here, John. Oh, there's something really. Oh, I need to change it. Username hash. Yeah, as you can see, it works. Sometimes it works and sometimes it not. It's a little buggy, but as I just explained to you, the single is trying to manipulate the string. So I provided all lowercase information, and it could find it could sorry it could find the uppercase string that we hashes. So if it doesn't work, just close the terminal and try to rerun it once again, or change the file, change the name of the file and rewrite it once again. It's kind of a little buggy, but that's all I just wanted to say. So single methods is used just to manipulate the characters and add some string at the end and at the beginning, or at the beginning of it. So let's try it once again with another string. So I'm gonna put Milad one. Yeah, I'm gonna hash this string and let me what the result is. So I come over here, echo, and I'm gonna assign it to username hash.txt, and I vim username hash.txt. I'm gonna append. Let me say I'm gonna append just Milad as regular, and I'm gonna rerun John once again. And as you can see, it could find it because single append a number at the end of the information that we provided for the John repair. So it works, but as we saw before, it was a little buggy. It didn't work, and it's kind of really uh, annoying. But if you run into some issue like that, try to close the terminal and rerun it once again, change the name of the file, and try to hash it once again while you get the same output as we learned a few moments ago. Because no matter how many times we hash the string, we hash the same string, we always get the same output. So let's come over here, and we're gonna go a level upper, and we're gonna learn how to crack hashes from etc shadow. If you are using, and I'm obviously if you are using Linux distributions, something like Kali, CentOS, or Ubuntu, Linux has two critical files to save the information about the users. One of them is etc shadow, and the another one is etc passability. In etc passability file, the Linux tries to save general information, including user ID, group ID, the type of the shell that you're using. It can be Bash, ZSH, or whatever. So, and in etc shadow, it saves two critical information, but the another one is in hashing algorithms. So it tries to save username and the password in hashing format. Okay, let's see how it works. So if I cat etc shadow, you see uh, on the left hand side before colon it's all the username. Okay, And on the right hand side, after the column, is the hashing format of the password for the username. It's already hashed in a yes script format because we have $sign white $sign over here. So if if it has exclamation mark, it means the user is logged and you cannot log in with it. So it's just wasting of the time. And it's also if it has asterisk, it means it's not also you're not able to log in with it, and there's no password for this username. So just look for the hashing algorithms after the username, after the column, which is in this format. So as I just told you, it's in yes script format. Let me show you how many hash types in onshadow files do we have. So yes script, as we just saw a few moments ago, yes script starts with $y $. SHA 512 crypt starts with $6 $. SH 256 is started with 5, and the other 1 and 2 egg and 2 y. So let's see if it's true. If, for example, bcrypt follows the specific pattern and it starts with $2a or not. I have a online bcrypt generator over here, hash generator for bcrypt. So I want to, for example, hash a string monkey. So let's see if we start with one of these two pattern or not. As you can see, it starts with $2y which we obviously have here. Uh, sorry, which we obviously have here. So yes script, as we saw, is the hashing algorithms that our Kali Linux use to hash all the passwords over there. So how can we crack it? As we saw for the single method, John Reaper needs some information about those hashes. So how we can do that? Without those information, John Reaper found it very difficult to crack those hashes. So we need to provide those information. How? So there is a tool named OnShadow. You need to have it installed on your computer. I think it's installed by default on your Kali Linux. If you don't have it, just install it. So, and then following the etc passwt, and then following etc shadow, and assign the output of combining these two files into a single file, which I'm gonna call it on shadow.txt. So if I list my files over here, is created the onshadow.txt. Let me cat it for you. Onshadow.txt. So as you can see, the onshadow combined all those two files together. So now we have the username over here, the hash format of the passwords, and the user ID, group ID, and the path to our home directory, and also the type of the shell that we are using here. So now how we can crack it? The first step, always remember, we need to specify and identify the type of the hash that has been used. So how? We know that the type of the hashes that has been used over there is yes script. So what's the specific format in John Reaper? The specific format in John Reaper is script. Let's list it. List formats grep I crypt. So as you can see, for hashing algorithms in for yes script hashing algorithms, we need to use crypt for John Reaper. But if you're using another hashing algorithms like bcrypt, it already has in it bcrypt, so you can use bcrypt for bcrypt. But for yes script, we're gonna use crypt. Okay, and for example, for SHA1, we already have raw SHA1, and the other one should be over here. Overall SHA3 should be somewhere here. I can't find it right now. It should be somewhere here. Yeah, but it should be here. It's not important for now. So for yes script, we're using crypt, and for bcrypt, it's already specified in the simple format bcrypt. So as before, we used John format crypt, a path to our word list, which is rock, and the hash. No, it wasn't rock.txt on shadow.txt. So as you can see, it could successfully find the password, which is tool for the user root. So we could successfully found the password and crack the hashes for the username root. It's really important to provide some information to for John Reaper in order to facilitate finding the password in hashing format or crack the hashes. It's really important. So we successfully found the password tool for username root, which is really correct. So let's come over here and go to the next slide. Another important thing in John Repair, we can specify and defining some rules for John Repair. What is rules? Custom rules allows you to create your own password modification patterns so the tool can generate new password guesses dynamically from a word list. Why they are useful? Organizations enforce password complexity. If sometimes in login page or registration page, you see the company asks you to follow a specific order to choose your password. For example, it asks you to um, definitely use an uppercase character, lowercase character, and a specific symbols like ampersand, a hashtag, or any other symbols. Users often follow the predictable patterns. For example, polo password could be polo password 1 exclamation mark. Attackers can exploit these patterns by automatically generating similar variations. How custom rules work? So there is a path to vim etc john.conf. That's where you can define your rules over here, which I already defined a rule here. So let's do it again. So the first thing you need to do is open a bracket and type list dot rules following a column, and this part after column you need to call or name your rules. What do you want to call your rules, or what do you want to name it? So for example, I'm gonna call it like before test over here, and exactly underneath your rules you need to define and specify like regular expression, the pattern of how do you want what kind of rules do you want to apply on your word list. So over here, uh, let me search it for it. Google uh, pat patterns or rules for John Reaper. John the Ripper word list rule syntax. As you can see, it gives you very comprehensive instructions about how you can use these options over here underneath your rules and what each of these options does. So for example, I'm gonna go for C, which capitalized the string for us. So let's go over here and I type C. So what does C does? It capitalizes all of our word list. So let's see how it works. John John word list ROQ ROQ hash dash 05 and rules test, and then I just want to see there is output. As you can see, let me read the normal file ROQ. So this is my normal file, which included some words in all lowercase. But as you can see over here, we applied the rules on our word list, and it capitalized all of the word that we have line by line here. For example, monkey with the uppercase M, but over here the monkey is with the lowercase m. So that's how you can apply your rules on your word list. So if you want actually apply it on a how to say on a hashes that on a hash that has for example uppercase, you can apply it without std out. Std out is just to show you and demonstrate you if the rules successfully applied on the word list or not. So let's try it. For example, I come over here and I generate the monkey with or let me generate a milad with uppercase M over here, and I put the result inside the hash.txt, cat hash.txt. So we successfully assigned the hash inside the file. So now we know we have the uppercase milad, so we need to apply for that. I used John format. We know the format. If you don't know, I just explained to you how to find and identify the hashing algorithms. So row MD5 word list raw queue, and we're gonna apply the rules on the word list rules test, and at the end the hash file. As you can see, it successfully could find the milad password, and it cracked the hashes and found it milad, which is successfully because we just which is successfully right, and because we just hashed a string milad with uppercase M, and it also could find the milad with uppercase M. So it means the rules that we applied on the word list successfully work, and we could find the string that we hash in MD5 format. So there's only one thing left to cover in this lecture. So as you remember, I told you that we have two different methods to identify the hashing algorithms. One is the online tools like hashes.com, but the other one is hash ID, which is written in Python programming language. So you need to install it on your computer, which I already have it on my computer, but I want to show you how it identifies and how it works. After installing on your computer, just write hash identifier, and it shows you with a banner over here with hash ID. So I'm gonna copy and paste it over here, and as you can see, it shows you a list of hashing algorithms that it thinks it correct for this type of hash. So as you can see, the most of and the majority of the lines is related to MD5, which is correct. And but let me show you another hashing. For example, let me come and copy this one and paste it. Let's see it can guess this one correctly or not. No, it couldn't find, not found, but the online generator over here could find it successfully. So let me paste it here, and if I submit and identify it, it found it as bycrypt over here. So hashes.com is more reliable and trustworthy than hashes ID, which is written in Python programming language. That's why I suggested you to use this online tool. But let's try another one. For example, sha1.hash. As you can see, it could successfully identify SHA1 hashing algorithms because the majority of the lines is related to SHA1, and also over here HMAC SHA1. So for now, let me exit this program. So thank you for watching. In this video, I did my best to cover all the basic thing and all the basic materials for John Reaper. Uh, it's really worth spending some time to familiarize yourself with other options. But I'm gonna make and release another video for intermediate and advanced level for John Reaper, how to crack the more advanced hashes, how to use that, and cover more options and arguments that John Reaper supports. But it's really worth spending some time to familiarize yourself with those options. It's really helpful. So I just tried to cover up basic things. Thank you for watching this video. If you haven't subscribed to my YouTube channel, please subscribe to my YouTube channel. And if you like this video, please give me a thumbs up. And I do my best to release and make some videos for Python and Swift and also some cybersecurity instructions. Thank you for watching. See you later.